Hello everyone, and thanks for joining us for our webinar on using metadata with object storage. Before we start, just want to get a few housekeeping items out of the way. Please ask questions throughout. We love to have informal webinars, so if you ask a question during the webinar, we'll go ahead and answer it. If for some reason we don't answer it, we'll follow up with you directly after the webinar or in the Q&A section. We also have some great attachments and links in the attachments and links section. So go ahead and take a look at those throughout the webinar or even after the webinar. And with that, let's go ahead and begin. So first, some introductions. My name is Adrian Hare. I'm the VP of Marketing. I'm going to be your moderator today, but the true talent on this call is Ryan Meek. And Ryan, why don't you introduce yourself to everyone?
Thanks, Adrian. Well, I'm Ryan. I've been here at Coringo for quite some time. I've been a developer, a tester, a trainer, a product manager, and now I'm a solutions architect. So I've seen quite a bit of the system, and I am looking forward to sharing it with you today.
So you've done it all, and since how long have you been with Coringo? It was founded in 2005. Were you here at the beginning or close to the beginning?
I was here maybe not at the very, very beginning, but very close to the beginning. I got here when our core product offering was still in beta. So that was more of the tester phase.
Yes. So that was a long time ago, and Coringo certainly has evolved since then. But as an organization, we've always focused on storage software and always continue to innovate. We're proven enterprise ready with hundreds of deployments worldwide. I mean, there's a lot of deployments across various different industry segments, verticals, and use cases. But at the heart of all those use cases is content, data that needs to remain accessible and identifiable. And that takes us to the next slide on metadata and the agenda and what Ryan and I are going to discuss today. And here are just kind of the high-level flow of what you will see. We'll go over some object storage basics. We won't really spend a lot of time on this. We have a really great attachment attached to this webinar if you want to learn more about object storage. We'll go over REST content APIs and applications, and then just kind of do the deep dive into metadata, specifically metadata and Swarm, and then we'll give time for Q&A and wrap up at the end of the presentation. But as mentioned before, please go ahead and ask your questions throughout. We love to answer questions as they come up. And with that, Ryan, take it away.
All right, thanks, Adrian. Appreciate that. And as Adrian said, we'll start with object storage basics, but I have a feeling a lot of people here are probably familiar with objects already. So we'll breeze right through them for the benefit of anyone here for the first time. Objects are, you can think of them as an encapsulation of data. It's data and its associated metadata. So if you think of it as like a capsule, metadata and data are kept together in objects. This is really differentiated from file storage that does not have a specific metadata facility, and we'll get into that. In general, object storage is focused also on data protection, high availability, and high performance. And what data protection means there is it is responsible in the system for not losing the data. It does not rely on an external system such as RAID. So in the object system, by default, many times that's by replication. It can also be by erasure coding or by a very specific kind of erasure coding, which basically corresponds to object level RAID, if you're sort of wondering what object erasure coding references. High availability is generally provided by multiple paths to either those replicas with the data and metadata, or to enough of the segments to reconstruct an object if it's erasure coded. And high performance is essentially built in by assuring that multiple servers can service requests and there are no single points of failure in the system. Namespaces, and what we mean by namespaces are the actual names of the objects are flat and often unique, so you can think of that as a globally unique identifier. And this is distinguishing from, say, a file system's more hierarchical namespace where finding upper directories are intrinsic to finding lower directories, and it results in a whole series of lookups into a system. In general, object storage namespaces are flat, run on a globally unique identifier that's indexed, and so accessing it's extremely fast. The front end for getting objects in and out of an object system is through HTTP. So I think there were really a few different ways of getting in and out of object systems years ago. There were a few proprietary interfaces built, but HTTP really won out in general. It's an open protocol. There are many client packages available in many programming languages. It's because it's the language of the internet. And so it's, distinguishing it from, say, a proprietary code API, HTTP is a clear winner, especially for the openness. Now the S there just means, hey, you may want it to be encrypted and secure also. So HTTPS, we'll be using those interchangeably going forward in this presentation. And the way you may have heard of object storage in the first place without even knowing it was object storage is through S3. And so I just wanted to plant a little flag here and point out that S3 is object storage. Objects in S3 are identified with globally unique identifiers as well as flat names. And those flat names exist in flat buckets. And the S3 protocol is implemented on top of HTTP and HTTPS. So years ago when we were saying object storage would end up being sort of the dominant paradigm going forward, we were very right. S3 is increasingly available across the enterprise suite of tools. It's the protocol of choice for much development going forward, and it's featured prominently as a protocol in Coringo Swarm as well.
And I think that's one thing that we should probably just have a quick discussion about, right? I mean, we've both been here a long time, and if we can point to one thing, it's really the adoption of the S3 protocol. And there's kind of two things going on here, right? There's the interface itself, and then the underlying storage infrastructure. And in your opinion, all the benefits you just went over, the object storage basics, I mean, do you get that with just S3 as an interface on top of a file system?
Oh, you really don't, because you can use the interface and the protocol is nice and it's open and it's easy to program to, but it's essential that it be architected from the ground up as object storage, because you do not want surprise performance problems resulting from reliance on legacy hierarchical file systems. We famously slow down if you put a couple of million or billion files in the same directory, for instance. And you don't get the high availability where, if you lose the machine that you're talking to, all of the same data would be available from other machines.
Yeah, absolutely, and that's a good segue to your next slide, correct? Showing some of the other benefits that you get using, objects as the underlying infrastructure in comparison to file systems. And the reason we bring this up is because there's a lot of file system enabled storage devices out there that are putting S3 in front of it and labeling it as object. And from our perspective, that's a misnomer. And at the end of the day, the end users will run into these specific issues, right? You already hit on high availability. You hit on kind of searchability and the ability to maybe list directories. And you're going to get to a few others on this slide, correct?
Yeah, and I think some key questions to ask there if you're trying to find out whether your S3 enabled storage is in fact on top of genuine object storage is, ask, is there a relational database back there holding metadata? Is there a hierarchical file system, receiving the content? And if the answer is yes, then you have a REST API on top of storage, and that's great. But you may not have the benefits that you would like to have through object storage with high availability, high performance. And the other points here in this slide I would just like to hit is the metadata being associated with objects really enables compliance use cases, policy management use cases, and downstream versions. A lot of times when people ask, okay, well, and we're going to get into it in subsequent slides, what is metadata and what does it do? Well, the metadata doesn't actually do it, but it enables you to get the value out of it later. So without further ado, let's go ahead and get there. So it's been in the news a lot lately. Well, what is metadata? Okay, so metadata is data about data. So if you have a photo, it would be the included information you may have seen identifying the camera that took the picture, or the effective shutter speed, or the associated items. If it were a satellite picture, it may be the latitude and longitude. If it's medical imaging, it could be the doctor, it could be the sensor, it could be the version of the software. But the data about the data will be key for unlocking the value in the data later. So it's data about data, it's information. Every object in the system will have metadata, especially because even things like name, what is the name of this, is metadata as well. It's highly optimized for HTTP, so you'll also see things like content length, size of the object, the time the object was written. This is all metadata. And the quote that I saw a long time ago that I was happy to actually find was, metadata is a love note to the future, attributed to Jason Scott at the Internet Archive. And that's really sort of to the point that it's unlocking future value. So when you're dealing with data and the metadata available about the data, unlocking value is going to be a key aspect. So it's really all of the above. And that's why we're here. So what do we actually do with the metadata once it's there? Well, in the case of, say, files, lots of the metadata would be in things like content type, HTTP headers, or file extensions, okay? So that information makes data playable. When you click on a file, it knows how to get the right player. If the names of those files were indexed, it makes it findable when you go and do search. A system that is bringing up tooltips or hovering, it's displayable. If you're searching on an entire class of data, say a compliance-related data, it would be actionable, or just clicking on a file, the system would know how to go get the right player to make it executable. So these are all sort of downstream use cases, although you may not have thought of them as use cases the first time you did them. They're all examples of use cases that take advantage of metadata in place about what you have. So to be super useful in the object system, and you want it to be fast, you want it to be simple, you want it to be portable, and this is really keeping up with just the core promises of object storage in general and the realities of working with data at scale. So let's say you're working with something like billions of tweets, okay? You cannot have something that slows down when you want to query it and find the million tweets that match a pattern. They really need to be portable to different aspects of the system. They need to be usable in the protocols. And once they are portable, simple, and fast, enabling structured metadata is super useful. We'll see that a little bit later, structured in formats like JSON, and then extensible to either new formats or, let's say, different either schema types or different arrangements of data that may be expected by sensors, for instance. So these are all characteristics that are met by object systems like Coringo Swarm that have been architected with them in mind. So really more specifically in Swarm, we'll get into what it will look like. So in an HTTP system, HTTP is on the front end. So very specifically, the data is the data of the request, and the metadata is in the text fields. Basic metadata are persisted with the objects. And you'll see a list here. I won't go through them by name, although, yes, I will. Name is super important. You can think of why, right? You need to be able to find it. And eTag, I want to just notice here because it will become the basis for versioning later. Those of you familiar with HTTP will recognize it immediately. And then full metadata field, you really want two different settings, I think, in a practical object system. One is, let's keep all the critical metadata and let's make it functional in kind of a minimal environment. And that's what the basic metadata setting is in Swarm. And the extended full metadata setting is, here are the additional fields we anticipate you would like to keep, and we will keep them. And we will also let you extend the patterns with your own custom metadata. So if you notice here, there's a star meta star pattern. And it's a very powerful facility. It means you can define your own custom metadata, and your own custom metadata headers will be persisted with your objects. So this is a very powerful facility of Swarm. It's matched by a facility in S3 if that's actually the protocol preference for interacting with the object store. That's fully supported as well. And there's a sort of pattern matching search query at the very bottom for those of you that would be interested in that. And I will
just a real quick question on that, Ryan. I mean, you mentioned S3 there, and I think one of the questions we get asked most often in the case of metadata is kind of metadata portability from different object storage solutions or clouds, or metadata interoperability. So how does metadata in Swarm map to, let's say, S3 metadata?
Yeah, so S3 metadata is mapped one-to-one through those headers and pattern matching to Swarm. So Swarm would persist headers in the same way and service requests with the same metadata headers in S3. And that's actually pretty critical for being an S3 compliant protocol. In particular, eTag is used as a key into versioning. And HTTP aficionados will recognize it as a facility that caching proxies, for instance, use when they're deciding whether their version of content needs to be updated or not. So they can just query the version tag, the eTag, see if they have the correct version of a file, and if they do, nothing needs to be reloaded. So it's being a well-behaved HTTP citizen in an event-driven architecture. That would be the geeky way of saying it, I think. Make sense, Adrian?
Yeah, it definitely makes sense. And I mean, as you mentioned, eTag, so my mind goes to a lot of our customers that are providing, on-demand use cases for content specifically, and this would save them a lot from a bandwidth transfer perspective if they are using caching layers and they have served that content before, correct? That means that if they've ever served the content before, it's still in their caching layer.
Absolutely correct. Yeah, absolutely correct. It's a critical aspect, and we fully support it.
And again, I think that it's one of the characteristics of object storage that kind of goes, those who know that, you can serve content directly from the storage layer. It's almost a misnomer to call it object storage because it does more than just storage. But this is key and this is critical, what you're reviewing and going over now, to this differentiation between, file system-based storage and true object storage, which also delivers content.
Yeah, you're exactly right. I mean, object storage over HTTP, you can really think of it as web access storage or web scale storage, and we work with the web tools and the web acceleration frameworks, the HTTP acceleration tools. Yeah, so that's a real critical part of, especially if you're looking at a long tail, a long tail content pattern where you need to keep petabytes of data up, but then service a request in milliseconds for a video that may not have been accessed in a year. You don't want that video to have to live on a forward proxy, so you want to be a well-behaved origin server, and we're absolutely great for that use case.
Absolutely.
So here I just wanted to get into a little bit more about how we do it. So we've talked a lot about what we do, and how the metadata is represented. So it's HTTP on the front end. So an HTTP request is data and text headers. So those text headers are actually indexed when the objects come into the system, and that's the integrated search stack part of what we've done. But where do they go? So I'll introduce it here. We actually leverage the Elastic Stack, which is an industry standard way of indexing text. It's very fast, and it itself fulfills a lot of the same promises as object storage. Shards are replicated, the system's highly available, and it's architected from the ground up to be very fast. Now, we are persisting the metadata with the objects, so these indexes can be reconstituted at any time for any reason, and they'll be done in the set that's appropriate for their cluster, so that's the portable aspect of what we covered. If your cluster has a certain subset of domains, then that will be the indexed subset as well. So the integration takes place, directly. As soon as the objects come in, the content is indexed, and then when searches or requests, say for domains within a cluster, or buckets within a domain, or objects within a bucket come in, those requests are actually serviced by the Elastic Stack as well, although they can be proxied through, and by default are proxied by the Swarm system. So you have one place to send requests where you can get objects, get information about objects, and get answers to metadata search. But in the background, we are leveraging the Elastic Stack, and it's an outstanding stack. It's available. It's open source. And there are additional modules that you can leverage as well, which will come up a little bit later. So we did introduce object versioning through the eTag, and that is the mechanism that Adrian, I think you were asking about too, especially about being a good origin server and being a well-behaved HTTP citizen. This is just a little bit more information about how it looks at a command line and at a protocol level. And what you can see here, I think, is that the eTag versions, correspond to the hash values in the request response handshake. But I think this gives you a very good idea of how it's done. You can see domains, you can see buckets, and I think just even moving up a level, you don't have to understand that at the command line in order to make use of it. So it may be difficult to see here, but the chooser on the left-hand side has a drop-down set of versions for a particular file. So on the previous slide, we were looking at, okay, how would you get different versions in the cluster available for the same named object in the same bucket in the same domain. But this actually here makes it available to an end user. So if an employee were a curator of a bucket of items and someone called in and said, actually I liked the previous version better, they would have a place to just log in, select a previous version and make it the primary. And they would have options in front of them like whether to delete previous versions, delete all previous versions. And it's all available at the command line. It's all available through an API, but we've also put a front end on it for your convenience. So in addition to those parts where you can surface versions, we also enable sort of search through the UI, and we also have a facility that takes advantage of search, which we call collections. And this really sort of corresponds to, I think, what a lot of people understand now as a smart folder, say a smart folder in your email, or as a, say, smart folder on a file system or a laptop. And that is essentially keeping and persisting a search where you say, all the files that match this pattern in their name or all the files of this type, and you get a dynamic list of objects that match that pattern. So, in practice, this has been used for things in our systems like, have incoming files been run through an antivirus detector, and if they haven't been through it, if they're newly arrived objects, they're sent to the antivirus system, and then once they've passed the antivirus, it would actually get tagged as having passed. So it's an easy way to query the system and say, what's the set of objects that haven't passed the antivirus? Should I make those objects available to the rest of the system? It's a very general way to tap into workflow and include processing all the objects in this bucket, or editing all the in a script format, editing all the metadata for objects in this domain on their way to another bucket, for instance. So very powerful mechanism, very much corresponds to something like a smart folder. And when you can operate on dynamic sets of objects, that's another key way of interacting with objects at scale. And there's no way to keep a list that someone has to change manually for millions and millions of files. It just doesn't work. So very nice facility in Swarm. And it's also available through the UI, and it's also available for downstream scripting with objects. And so just wanted to also share here, so since we introduced using the Elastic Stack as a facility for indexing metadata, that Elastic Stack is available on servers, and it's extensible in its own right. So we are leveraging modules that you can take advantage of, and in this case, this is Kibana. So you can customize dashboards, you can run your own reports. In this case, it's file types, and it's showing a pie chart with different levels with file types against file sizes. This can be a great, and there's actually a selector for the amount of time window to choose these files over. So this can be a great runtime engine for things, doing analysis on all the objects you may have that you may even, that you may not know about. So Our systems have been used in some cases for intrusion detection systems and packet grab, packet analysis. So, being able to find all of the incoming packets from, say, a particular set of IP addresses once an intrusion has been detected. I mean, it's a really key aspect of the system to be able to do it at runtime with no additional changes and have it be responsive. So building the metadata facilities in the right way, that not only do you stick to the core promises of object storage where it's highly available, the data is protected, and you have a clear visibility into all of your objects at all times, but that you can leverage industry standard metadata facilities at the same time. It's really a key aspect of Swarm, and it's a key part of unlocking the value in your data. Someone said to me really recently that data is the new oil, and I think what he meant was data is the new place where there's a ton of value ready to be unlocked. Well, you need a good metadata facility in order to unlock it. We've been very focused on delivering that over the years, and it's been a pleasure sharing that with you here today. So, Adrian, do you think there's any other points I should hit here before we wrap up?
Well, I think we can kind of open it up to questions if anyone has a question right now. But as you were talking, you mentioned a lot of different sources of metadata, and how, let's say a user has metadata in a specific application. Let's say they use an asset manager, and then they maybe have some other devices, whether they're cameras or some other sensors. How do they get the metadata into Swarm? How would that be done?
Well, it really depends. So if they're writing their own, it would be including HTTP headers in the request that correspond to a star meta star pattern. So company name, meta, description of the file coming in, and then that header would be persisted with the object, and then that header would be sent to Elastic to be ready for search queries, for instance. If the incoming data had standard metadata, like that's enabled with a certain format, many times there are plugins available on Elastic to automatically incorporate that kind of data. So it really just depends. If there's sensor-specific metadata, many times there's modules, and when people are writing their own connectors, then the star meta star facility is the way to tap into the custom metadata. That's a great question.
And early on, you mentioned that you made this comment. It was a small comment on the side, but no databases, please. Why is that?
Right. Well, I mean, it's an entire industry's job to keep those metadata, or to keep those relational databases running. They have unanticipated performance problems at scale, and they aren't good at running by themselves. So you can certainly make relational databases scale. You can certainly get smart DBAs, and that can be their whole job. But architecting a system that has very dependable performance characteristics with billions of objects, or as you scale up, I mean, you can install a system here with 10 nodes, and you can grow it to 1,000 nodes with no changes in the architecture. That's just not done with relational databases. They really have to be scaled. They have to be scaled where one instance scales or two instances scale, and that's just that's a very complicated way of doing things.
So I guess if I can repeat what you said in a different way, you mentioned scale and just overall number of objects or number of files, and you also mentioned not being able to define the structure or the schema beforehand. Correct? I mean, is that
right.
one of the
These
issues?
are all. That's right. So these are all. I wouldn't say they're schemaless, but they're flexible with respect to schemas. So you can change custom metadata at any time, and you don't need a DBA to put in a new schema to take advantage of it in an object storage system. So the object storage is much more flexible, and it scales by adding machines, not by adding people or by getting, you know, a larger SAN, for instance. It scales with standard hardware. Yeah.
Absolutely. So with that, we have no additional questions. Any closing statements for our viewers?
No, I would just say if that's interesting, look us up, get in touch. We'll certainly follow up with you after this call if you'd like. Love to share more with you about it, and we'll look forward to doing so.
Yeah, and again, oh wait, we have a question. Last second question, I would say. Would you be able to explain more about how the data is protected and how it's high availability performance built in object storage? So, yeah, how data is protected and high availability performance that's inherent in object storage, specifically our object storage.
Yeah. So, so data protection is either by replicating the data between different servers, or by slicing the data and then using, you know, what would correspond to like an object level RAID. So we call it erasure coding, but it's essentially slicing the data so that you can reconstitute the data from any set number of segments. So, you know, in a 5-2 erasure coding strategy, there would be 7 segments, and the data could be reconstituted with any 2. And high availability is intricately related because you can lose as many different servers or disks and still have availability to all of the objects. And performance is delivered because there's no single point of failure in that system. And through using globally unique identifiers to all of the objects and to all of the segments, you don't have to traverse a hierarchical file system. So all of the objects ultimately have a universally unique identifier. All identifiers are indexed in RAM. And so you can go straight to disks from RAM and service requests. You do not have to traverse disk hierarchies. You can go straight to the data. So I think I got to each aspect of that good question. There's a lot there.
Yeah, and I think
metadata, I would say even metadata in particular, if you get into that data protection and high availability, that is done through sharding, which is basically replication. So I think what I said before applies as well to sharding and replication with metadata.
Yeah, absolutely. And I think, you know, maybe just a very high-level description of one of our customers who's a web scale customer who interestingly moved to Swarm for scale, but also protection of their metadata, the actual data that they use within their web application. That was one of their issues using a relational database, is protecting the data in the relational database, and how much easier that was done through Swarm specifically because of the built-in you know, geo-replication functionality. Mm-hmm. So you know, it's not just protected on site.
That's a really good point, and we hadn't even touched on that. So it's, I mean, it's replicated for high availability in one location, but it's also, you know, geo-dispersed into multiple locations in a consistent way. So that's data protection at, you know, the level of even losing an entire site. So that's a really great point too, Adrian.
All right, we'll give everyone a few more seconds to ask any questions. We do have attachments and links, as Ryan mentioned. You know, you can always feel free to send us an email The general email address is info@coringo.com. If you ask a question there, it'll get to the right person. We also have our next Tech Tuesday webinar, using Firefly to manage your data. Firefly now supports tiering data from Windows and NetApp to Azure, Google, Amazon, in addition to Coringo Swarm, of course. And we have a number of great webinars, Tech Tuesday webinars, and also some more kind of thought leadership webinars within our webinar section on our website, and also across our Bright Talk channel. So, please visit all of those. And with that, Ryan, I don't see any additional questions coming in, but would like to thank you again for your time and support on this webinar.
Thank you, Adrian, and thanks everyone for joining.
And that concludes our webinar. Thank you, everyone. Thanks for your time.